Common mode chokes. Well, they're not bad, but most of the time they're quite useless. If I get a design and I see that there is a common mode choke in the power supply, I know that it's a bad PCB. You need common mode chokes if you have common mode noise. And this happens if something totally fails in your design. Normally, you don't have common mode noise. There are very few examples. If you go to power electronics, so 2 years ago, we designed a 68 kilowatt power inverter for this high power charging. You'll see some pictures later of the charging. You put the SIGMOS devices on the cooling plate. And between the gate of these devices and the cooling plate, which is normally grounded, you get a capacitor. This will give you some common mode noise, independently of the amount of power you put through this. You just start switching without power, just switching the gate, and you get common mode noise in the whole system. This is something you cannot avoid. Then you need common mode chokes, such rings, just ferrite material, 1.5 to 2 kilo each. That's another world. CAN bus is a great idea. That's why I said they are useful for symmetrical signals. CAN bus is a symmetrical signal. USB, Ethernet, all that stuff, and you have many more. Maybe audio signals, you have symmetric audio and you need to filter it. It's great. If you have symmetrical signals, they are great, but not in power lines. Power lines are, by nature, unsymmetrical. It's ground and plus, whatever it is. So sometimes they give you the 3 dB, and it helps you to survive the measurement. But that's what I said. You just move a little bit the problem, but you don't fix it. And different car, different type of wiring harness, same problem again. What do you do now? Apply the next common mode choke? No, that's a bad idea. Don't use them, you don't need them. Try to make your PCBs clean. Next thing is, with a common mode choke, you put an inductor into ground. You cannot imagine how often I see people putting resistance into ground. Ground is your reference. This is where everything wants to return. This is your return path. If you put resistance into ground, how do you want to apply filtering? It's blocked at this point. So pretty useless and needs rework in 100% of the times. Ground layout, we just were talking about grounds. In 2017, I asked the same question. How many grounds do you think we need? Yeah, you know this. You have analog ground, power ground, signal ground, digital ground, fantasy ground, whatever. No, you just have one ground. It's the same as Dan Beaker said. You need one ground. I made the head unit for a Porsche 918, quite a complex system. We had 3 software-defined radios. We had video links. We had connect 3 displays, all this high-frequency stuff inside. We got one single ground, even with analog audio. You don't need several grounds. Get your currents controlled. If you know where your current is flowing, you need only one ground. If you don't know anything, have connectors everywhere and put the switching voltage regulator on the opposite side of your connector, you get current crossing everywhere, then you're lost. Then you need different grounds. But then you also need good assistance to survive the EMC measurement. If you know where your current is flowing, where your space is showing up for the currents, and that's exactly his idea, then you can survive with one ground. Everything is connected the same. You have something that is worth being called a reference, and you can apply filtering whenever it's needed.